I think this first one, right beside, you can do this right away. Bracket, 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 bracket. Okay, I would think about my first ones and my last ones, just like we've been doing all along. Let's have some fun. Once you got it, go, woo! Something a little bit crazy. Should. Do you get it on? Woo! Come on, Ben. No? Not good. It's, you get it?
Oh, wait, yeah.
Yeah? Woo! So you're like you're going off all over the place in here. No, you guys, it's Friday. Can I have a little bit of excitement? How about a little bit of, can you tap on your desk once you do it? Yeah? See, this is disappointing for me because I'm like, nobody's getting this factoring. So you get that first one, just so scared. You're like, is it because you don't want to be like, oh, I haven't got it yet, and don't want to do it yet? You know, you get it? Not yet. Okay. I'm distracted. Right. Did you get that the first ones had to be x and x? Yes? Benner, did you get that the first ones had to be x and x? Yeah. All right. Can you yes! Right. Okay. Now 24. We need the outside and the inside to make 5. So basically we're thinking what two things multiply to 24, and then we look at our outside and an inside. We need to make 5. 8 and 3. Isla, did you get 8 and 3? Yes. No. Oh. I don't know. I'm gonna crash tonight. It's gonna be disastrous. 8 and 3. And then to make it plus 5, the 8 would have to be plus 8. The 3 would have to be minus 3. I think factoring is one of the most enjoyable math things you can do. Because you get to multiply and add, you get to practice all your mental math skills, which technically you will use every single day for the rest of your life, whether you like it or not. Those kind of math skills you need for sure. And higher level math just gets you to practice them in unique ways. Like we do fractions all the way through grade 12, but we don't just do adding fraction questions. We make them more complicated. Okay, second one. Now, in part B, this is where we up the level of the factoring just a bit. Okay? You have two options. I will show you the better option before I tell you the worse option. The better option is to go, oh, this looks like something squared plus something times something minus something. It looks like that, but the something squared is now x minus 6, which makes it a little bit more difficult looking. If this was just a nice letter other than x minus 6, maybe it would be easy. So we do that, okay? You pick your favorite letter that you think has been neglected. Q. Q. Let Q equal x minus 6. And then we can rewrite this, and wherever there was an x minus 6, we now have a Q. And it looks easier to factor. Now, before you jump into factoring like we did in the first one, always look at your equation to see if there's anything in common in all the terms. So we have 3 terms. Is there a number that could divide all 3 of them? It's a 2. So the first thing in factoring this one is you will take out that 2. taking a 2 out of the first one, dividing this one by 2 would give me 5q. Oh my goodness, this is sure looking similar to something we did in part A. Is it identical? It is identical. I mean, it's a cube instead of an x. Basically the same thing. So as a result, we would know this is q and q, 8 and 3. The 8 had to be positive, the 3 had to be negative to make everything work. And at this point, we had substituted p equals x minus 6 early on, and now we're going to substitute back. So I had 2 bracket, and where the q was, I'm going to put x minus 6 back in, plus 8, bracket, where the q was, I put an x minus 6 back in, minus 3. When you substitute something into an equation, it's good to put it in brackets. To make your work easier to understand, notice that I'm using different sizes of brackets, so that I can be like, oh, it's really easy to see where one bracket starts and one bracket ends. This makes your life a little bit easier. And as a result here, inside this set of brackets, I have like terms. What's minus 6 plus 8? X plus 2. What's minus 6 minus 3? X minus 9. And this becomes our final answer, factored completely. And we did it by doing a little substitution. This is the easier way of doing this. Okay? Most of the time, students see the more difficult way first. Okay? I'm not going to do the most difficult way, but the more difficult way in part B would be actually to multiply this out. X minus 6 and square it. X minus 6 times x minus 6. FOIL it all out, then multiply it by 2. Distribute the 10, so you get 10x minus 60. Combine all your like terms, and then once you have a new big thing, factor that at the end. But that's a little bit more work. It will work. In fact, if I multiply this out, if you wanted to try the other technique, can you see that this would equal 2 times x squared? Last one will be minus 18. Outside and inside will give me minus 7. And if I distribute that 2, I get 2x squared minus 14x minus 36. If you multiplied everything out in B, combined all your like terms, that's what you would get. Unless you make mistakes, then you get something different. But that's not the goal. Okay? So part C. Everybody done writing down part B? Yes? I am a little disappointed with you guys that you're not like willing to like do some hoots and hollers and I don't know. I've always wanted during the exam, certain questions when there was an exam, it's like, okay, you get this question right during the exam, Big Jim. Just like, woo! So everybody is so quiet. No. Can you see you could do the shortcut for this one? We have another letter that we feel has been neglected. There's certain letters that are avoided sometimes. Like sometimes they avoid the letter T because it looks like a plus sign. Or the letter O, because this really looks like a 0. That's that one I never. J, okay. I like it. Let J equal 2x plus 5. Can you see that that would be the good substitution? Because then I would have 3j squared plus 10j minus 8. Is there a common factor? No. Since there's no common factor, we're going to use this strategy. We look at our first one. We look at our last one. Set out our brackets. Okay. Is there any one of them that only has one option? 3. 3 only has one option, so we'll go 3j and j. Now for the 8, we're going to have to think about this simultaneously. Two numbers that make 8 so that your outside and your inside make 10. And you'll start to notice that if it's a minus 8, you're going to have to be subtracting. If it's a plus 8, you're going to have to be adding. So the minus 8, not only are we looking for two numbers that make 10, we're looking for two numbers that when you subtract, you get 10. But they still have to multiply to get 8. Okay? Including this 3, I'm going to put the 4 here. That makes 12 and 2. 12 and 2 makes 10. Which one should be positive? Which one should be negative? I want positive 10, so I'd like my 12 to be positive and my 2 to be negative. And again, once you factored, you should quickly multiply that all out, check the first one's work, to the last one's work, to the outside and the inside. Still give me the right number? Yes. Substitute back. So now we have 3, and j was 2x plus 5 minus 2. 2x plus 5 plus 4. And we have to simplify. Distribute the 3, you're going to get 6x plus 15 minus 2 plus 13. And here, 2x plus 9. If I multiply this out, just for fun, because mental math is fun, 6x times 2x would give me 12x squared. 13 times 9, ooh, is that 117? We'll go with that. And then my outside and inside, I'm going to have 54x plus 26x is going to give me 80x. I can tell you right now that if you had that question, mental math-wise, trying to factor that would be hard. 117. Right? You'd be like, oh yeah, tip of my tongue, 13 times 9. Right? It's like, yeah, that's the number I know best. Okay? It's funny, my dad with his work, he had a custom business that picked up square bales for farmers and put them on a machine that stacked them into big stacks. And then he charged a certain amount per bale. And it was often a weird number, like depending on costs and stuff, some was like 29 cents per bale. So then if it was 29 cents per bale, he knew his 29 times table like crazy. Plus, one whole stack held 160 bales. So he also knew his 160 times table, because he would finish up someone's thing and say, oh, there's 13 stacks. So what's 13 times 160? How many bales times the 29 cents? And have to, you'd have a calculator for some of it, because some of it got crazy, but he could do a lot of that mental math as a result. Okay, but I would say factoring that, not so easy. Factoring the technique we just did, not bad at all. Questions for practice on this one? Are 15 and 16.